And the time is for Anca HIENOLA. Sorry, Anca, we wait for you. Thank you for taking the time to join us today. I'll give a little bit view about you. Şimdi sıra Anka'da Helsinki Üniversitesi'nden atmosfer fiziği alanında doktora derecesine sahip Anca ve atmosfer bilimleri ve iklim değişikliği araştırmalarında 22 yılı aşkın deneyime sahip. 2017 yılının başından beri de açık veri ve açık erişimi içeren faaliyetlerde, araştırma altyapı faaliyetlerinde yer alıyor. Enrifier'de koordinatör, EOSC Feature'da görev lideri, EOSC Nordic'de yine ve 3 Avrupa Açık Bilim Bulutu projesinde derinden yer alıyor kendileri. Yes, Anca, the floor is yours. Thank you. Your voice is microphone is
you are muted.
Is this better now?
Yes, this is better, thank you.
Can you see my screen?
Not the full screen. Yeah, yes, that's not okay.
Okay, I'm just afraid that I cannot do better than this. Anyway, thank you very much for inviting me here. It was quite a surprise, I have to say, but also it's a very big pleasure. I am a climate scientist by training, but I moved towards open science several years ago. And today I just want to share with you what is the good, the bad, and the ugly in the open science in climate research. The great majority of the environmental scientists have concluded that the Earth is at or near a dangerous climate tipping point. Climate change interacts with and exacerbates many other environmental and societal problems. These include air and water pollution that compound health issues, widespread and frequent droughts linked to extensive fires, diminished resources for drinking water and irrigation, large-scale biodiversity losses, including species extinction. Related factors include deforestation and soil erosion, consequences of overexploitation of natural resources for human use. Documentation of all these problems and many others is of interest to the broader climate community. It scales from local, very local to global. Climate change can only be realistically understood with satellite observation, with in situ observation, all this in combination with climate models to reveal patterns and trends that enlighten the understanding on how the current conditions have developed from past environmental drivers in order to predict future conditions. Worldwide, although regulations exist, access to information about the ecological state of global ecosystems is limited to the public and sometimes even to the experts, even in this new era of open science. Governments are notoriously reluctant to share data and information that exposes their own resource use and policy priorities. When data are shared, it can be so that it's incomplete, inconsistently measured, outdated, and overall inadequate for a comprehensive understanding of the underlying processes at work. But before diving into what is very wrong in this world, let's start with what is good, with a drop of optimism. I promise you it will get worse. The broad scope of climate change impacts means that successful adaptation and mitigation efforts will require an unprecedented collaboration effort that unites diverse disciplines and is able to rapidly respond to evolving climate issues. Let's look a little bit at the publications. So in order to achieve this aim, climate change research practices need to be updated. And one of the practices is to remove the key research findings from behind the journal paywalls. In this world, things are moving towards better. This is not a very updated figure. It's stopping in 2016, but anyway, you can see that the proportion of open access studies increased substantially over time in publication containing climate change words in their title, abstract, and keywords between 2007 and 2016. So in 2007, open access publications accounted only for 4%. But they increased rapidly to 25% on average in 2016. However, this varied by journal rank. Across all journal ranks, open access climate change studies were cited more than the closed studies. Beyond academic citation advantages, open access climate research can have a greater societal impact when studies are communicated to non-academic audiences by mainstream news and social media, as well as used by policymakers. And I think this is an extremely important aspect. So when the policymakers lack institutional access to paywall journals, the open access effect may result in a greater uptake of primary research in policy. If we are moving now to data, so first of all, we must recognize and also celebrate the efforts to becoming open of several large institutions and programs and initiatives that systematically acquire consistent environmental observations. NASA has been among the first in the world to establish a free and open policy for data. Similar values of transparency and reproducibility in climate research have also several others in United States, like NOAA and ESIP and GEOS, which is the Global Earth Observation System of Systems. In Europe, we have also the GEOS sister, EuroGeo and Copernicus, very well known otherwise. And of course, the European Space Agency and the environmental research infrastructures. Another sister of GEO resides in Asia, and a similar initiative there is also in Australia. All these programs deliver a massive amount of rich and high quality data related to environment. We should applaud as well the climate modeling community. And here I will mention only one, the CMIP-6 couple model intercomparison project phase, which is a project of the World Climate Research Program, which started actually in 1995. And has coordinated climate model experiments involving multiple international modeling teams worldwide. I think there are around 50. Their results have been open since the beginning, so since 1995. These model simulations have also been regularly assessed as part of the IPCC, probably you all know about this, the Intergovernmental Panel of Climate Change. Reports and various other national assessments. But in the end, it's not only about these big initiatives. Open science, it's a state of mind, and therefore we should acclaim the people, because the main work resides on the shoulders of our climate scientists as they are transitioning from their usual routine to the new open science environment. It is a climate of change, which requires complex systemic changes, which involve cultural behavioral interventions, as well as infrastructural solutions. Researchers can learn more about data publishing and licensing to know how to share their data. Universities and research institutes also have dedicated support, like data stewards that can provide advice and guidance. And there is also a need for a more technological innovation and for more social innovation as well. And now I will start with the fun part, the bad, and let's do it. So many times we are hearing that the climate scientists are complaining because of the lack of data. Why do they complain about that? There is an abundance of data in climate out there. If we take a look at this, this map, we can see the international climate data repositories. There are 38 of them. And just as an example of international data repository, it's the GEOS portal that I mentioned before. Let's add to this the institutional climate data repositories, which are in red, 101. And remember that here I did not mention the general purpose repositories that can have plenty of climate data, like Zenodo that everybody knows. The national repositories, the repositories of the environmental research infrastructures, which in Europe are functioning under the ENVI community umbrella with massive amount of high quality measurement data. And of course, those repositories that did not yet register with the RE3 data that it's shown here. So why would a climate scientist complain about the lack of data? Well, as we will see, that when it comes to climate data, open, it's not enough. There are several conclusions that immediately we can draw out of this figure. The number of repositories is actually a nightmare scenario. The climate scientist is a traveler between 200 or so data repositories, wasting precious time in search of proper data. The huge number of data silos, it's a barrier in itself, as it actually limits the access for ordinary researcher who is facing data fragmentation and unequal access to quality information. High number of repositories means, of course, higher heterogeneity. Each repository with its own or none, not at all, standards. And from the researcher perspective, with a lack of harmonization across diverse data sources, much valuable research data will remain underexploited. Climate data volumes are at all time high and are predicted to continue to rise rapidly. However, the storage does not increase at the same speed. So this fact, the storage limitation is one of the issues that will continue far into the future. There is another thing that we can see here, and I think this is kind of striking. Where there are repositories, there is a demand for them, which means that these are the places where the climate science is conducted. What we see here is that the climate conversation continues to be dominated by the voices of selected groups from the wealthiest countries. This is unfortunately a picture of a global scientific system that undervalues and underrepresents the perspectives of a silenced majority of historically disadvantaged groups, particularly those from Global South. Open science carries with it the promise of distributing power and opportunity to define and tackle climate challenges, but it will do so if only those who participate in science represent the diversity of society from all corners of the world. And I think that one lesson that would be to prioritize approaches to open science that supports diversity and inclusion, and abandon those who serve short-term national, commercial, or political interest at the expense of a truly global and inclusive system of climate science. Too much open data becomes strangely a barrier in itself. For a discipline like climate research, solely analyzing data or applying statistics without a deeper causal thinking has little to offer to our society. Early career researchers, PhD students, postdocs, in their majority spend a tremendous amount of their time producing and analyzing climate data. This obsession with data-intensive activities consequently inhibits the progress of other important frontiers of climate research, such as developing novel research ideas or developing scientific hypotheses. In other words, we are totally failing in educating young scientists how to produce research that can break new grounds in climate science. And now if that was not bad enough, I have worse. When scientists discovered a planet in our Milky Way that is made of diamonds, public fascination and admiration was assured. Who is not amazed by the idea of a bright diamond sparkle in the night sky? However, when scientists discovered that burning fossil fuels causes climate change, then the public and political response is much less favorable, with scientists being verbally assaulted or having their reputations questioned. While it is evident that open science in general does democratize climate science to some extent, certainly at least for those who can understand its content, in isolation, it's not enough, and other actions should be considered. Because in our rush to prioritize open science, we have left the world behind. Access does not equate accessibility. Despite access, the information remains inaccessible in any functional sense. People cannot apply it, cannot understand it completely. People cannot put it into context. The information is accessible, but the person has no access to its real value. As people are feeling shut out of the powerful and unintelligible world of science, we, the scientists, have to pursue yet another path, which is the state-of-the-art science communication, in a bid to not further alienate an already fearful and suspicious population. For out of fear and uncertainty, conspiracy theories are born. When a conspiracy theory is applied to a scientific result, people may be misguided and interpret information in a wrong way. Scientific misinformation produced as part of these wrong interpretations may have widespread and detrimental effects on our society. Climate change is maybe the supreme example of proportionality bias. It's a global scale event with enormous significance, and it is portrayed by scientists and the governments as consequence of a small everyday factor, such as the transportation that we use. The problem, I think, becomes especially acute when people are in the decision-making power position. And I will give you only two examples here. I don't know if you know the question and answer talk show running in Australia. Well, one time, Australian Senator Malcolm Roberts asked Professor Brian Cox to show him empirical data that proves global warming. Professor Cox was obviously prepared, and he took out a graph showing the average global temperature, data which is provided by NASA, and they are open, yes. And the dialogue that followed, it's like from a parallel universe. So the senator said, well, the data has been corrupted. What do you mean by corrupted? It has been manipulated. By who? By NASA. Everybody was puzzled. Cox was puzzled. The audience was puzzled. Every single normal human being in this world would be puzzled, because it looks like even you have open data, which might be so that it's coming from completely independent sources, and they show the same thing, it's not enough. Can you guess who is the next one? Well, where should I start here? He likes tweeting, right? Climate change is not a real problem. It's a hoax invented by the Chinese. It's a conspiracy, and we know very well also his weird anti-science obsession with hairspray. But anyway, after he took office in 2017, his administration made decision after decision after decision that slowed or deprioritized climate action. It rolled back policies that helped mitigate warming, relaxed regulations for climate polluters, approved the Keystone pipeline. He made the totally insane decision of leaving the Paris Agreement, and the list can continue forever. Anyway, scientists attempted to quantify the impact of Trump's rollbacks, and they estimated that these rollbacks will increase the United States emissions of greenhouse gases by 1.8 gigatons cumulatively through 2035. So this is on top of whatever they are emitting right now. The problem is that these are the people that are in power and they are leading us. And the problem again is that an entire planet pays because of some their scientific illiteracy and mistrust and misunderstanding of science. We have to understand that no amount of self-delusion and political spin or fake news can ultimately protect us from reality. We have a shared destiny and also a collective responsibility. There exists a need to agree on what is essential to humanity, like staying healthy, live long, and prosper. And for this, we need to trust science because despite its limitations, scientific research remains the only tool humanity developed to solve the big problem of climate change. Thank you very much.